of the statement that the sum of 1 over n to the p converges if p is greater than 1 and diverges if p is less than or equal to 1. That's the proof of that statement. Now, once we've got that statement, that's all we've got to know. I mean, I'm not going to ask you to prove the p-series test on the thing. So I could say, suppose p was positive and ask you to do one piece of it. I could ask you, suppose p is positive, does this integral converge or diverge? You ought to be able to do each piece of that. But I would never ask you to prove the whole thing. But this is a proof of the statement, which is what we call the p-series test. So that tells you right off the bat that when you look at 1 over n to the 5th, you know it converges. Doesn't matter where it starts. N equals 1, n equals 10, doesn't matter. That series converges. It's a p-series and p is bigger than 1. The only other thing you have to worry about is, does it have some other term in it or something like that? Now that's no longer a p-series as it's written, but all I've got to do is mess with it a little bit. Factor out the constant. Now it is a p-series, right? Times a number. So identifying which one of these guys converge is usually, at first, right now, the only tools we have are, can I integrate it? 1, is it a geometric series? 2, is it a p-series? 3, if it's neither of those, can I integrate it? That's basically the only tools you have. 4, just like with integrals, can I do some algebra and make it look like a series that I already know converges? Factor some things out, break it into 2 series, each of which converge, some trickery. As an example right there. That's not a p-series. You can't just write on the test, hey, it's a p-series, it converges. You can think, hey, it's a p-series, it converges, but you got to convince me that it really is a p-series with a couple of algebraic steps. Questions? Questions on any of his steps, what he did up here? The hard part is just analyzing this, right? And analyzing this. And analyzing this. Right? What happens depending on the value of p? That's what's hard. All right?